Hi, this is Professor Muldrow, and today we're going to talk about how Java does basic math operations. First, let's define what an expression is. As you can see here, it's any math expression that calculates a value. Here we have three examples. The last one's just a simple literal value, a single number. The math operations Java uses are as follows: a plus sign for addition, a minus sign for subtraction, an asterisk or a star for multiplication, a forward slash for division, and finally a percent symbol. When you put a percent symbol between two numbers, you're going to divide the two numbers, but the result you get is the remainder when you divide. Now, addition, subtraction, multiplication, pretty straightforward. Those work just like you expect them to. Division, however, is a little different. In Java, when you divide two numbers that are integers, the quotient is also an integer. When I say a number is an integer, I mean a number that has no decimal places or a decimal point. So as you can see in this example, 14/4. There's no decimal point on the 14, there's no decimal point on the 4. Now, if you were to divide 14 by 4 on a calculator, you'd get a result of 3.5. But in a Java program, if the Java compiler sees that you're dividing and it sees that both the numbers are integers, the result is going to be an integer. So in a Java program, 14 divided by 4 is going to be 3, not 3.5. We don't round, we just truncate or drop the decimal places. This is something you need to be aware of when you're doing math in a Java program. If you divide an integer by another integer, the result is not going to have a decimal point. It's also going to be an integer. You only get the quotient. The percent operator only works when both numbers are integers, and it gives you the remainder. Here's 14% 4 again. So what Java is going to do is it's going to divide 14 by 4. Once again, our quotient is 3, but as you can see down below, the remainder of that division is 2. So 14% 4 is going to give a result of 2. Similarly, 218% 5 means you take 218, divide it by 5, you get a quotient of 43, but since it's the percent symbol in the middle, you get back the remainder, which is a 3. So the percent symbol gives you back a remainder. As far as precedence, meaning order of math operations, the good old PEMDAS, or please excuse my dear Aunt Sally, that you learned in algebra still applies to Java. Anything in parentheses gets top priority. Parentheses always wins. Multiplication and division operators have higher priority than addition and subtraction. So as you can see here on 6 plus 8 / 2 times 3, we have no parentheses, and division and multiplication get top priority. We go left to right. Divide the 8 by the 2, that's how you get the 4. Then multiply the 4 by the 3, that's how you get the 12. And then finally you add the 6 to the 12 and you get your final answer, which is 18. All right, let me show an example of Java code that does this. Now in this program you're looking at right here, the first part that I've labeled part 1 has a bunch of math operations. And all I'm doing is I put the whole math expression into a system out println. That will give me the output. And when I get the output, for the first part I get this. So 9/5 will give me an answer of 1. Again, 9's an integer, no decimal point. 5's an integer, no decimal point. Therefore, it's integer division. 5 goes into 9 one time. The answer is 1. The second example, 695% 20, remember that's the percent operator. So that's going to give you a remainder. If I were to do 695 divided by 20, I get 34.75. But I don't want the quotient, I want the remainder. So if I want to see the remainder, I do 695 and then I click this mod button on my trusty Windows calculator. If I mod that with 20, I get a 15, which is the remainder when I divide 695 by 20. I'm going to let you take a look at the rest of these math expressions and see if you can use the correct order of math operations to get the remaining answers. Now then, what you're seeing in parts 2 and 3 are variable declarations to start with. Here I have 5 variables declared. One is named val1, val2, then val3, val4, and val5. The first 3 vals, if you will, are of type double. Whenever you declare a variable in Java, you must first put what type you want the data to be. If you want your variable to have a possible decimal point in it, you use the type double. If you want it to be an integer with no decimal points, you use the type int, int. Now, it is not required for you to give the variable a value right here in this line. I could have just said double space val1 semicolon and then given val1 a value with a math expression later in the program. Either one is valid. But what's going to happen is this math expression will be calculated down to whatever answer it is. You're going to get one number out of this, and that one number is stored in val1. This math expression will be calculated to one number, and its value will be stored in val2. Same thing for val3, 4, and 5. Now you'll notice something on val3, 4, and 5. I've got something extra. I don't just have a math expression. I have this int in parentheses. This int in parentheses is one example of a technique that we call casting. This is how you can give, well, actually, how you can change the type of a number to a different type. So, for example, if I have just 4.75 and I put int in parentheses in front of it, that tells the Java compiler to take that 4.75 and make it into an integer, no longer being a double value, because doubles have decimal points. But one thing to be aware of, casting does not round, it just truncates. So notice, if I do int on 4.75, I do not get a 5, I get a 4. Casting does not do any rounding, it just drops the decimal completely. That's called truncating. Now, furthermore, when you use casting with parentheses, here you have a math expression, 9.7 divided by 3.4, and here is my int casting out in front. Well, since there's no other parentheses, the casting of integer only applies to the 9.7. It doesn't apply to the 3.4. So what's going to happen in that instance is that the 9.7 gets converted to a 9, but you're still dividing by 3.4. And you get 2.64705, etc., etc. But in this example, here I have 9.7 divided by 3.4, but it's all in parentheses. So that means what's going to happen is we're going to divide 9.7 by 3.4. And that gives me 2.8529, and so on. But then once the division is done in this second example, then you apply the typecasting. And so you take 2.8529, all that, and apply the typecasting, and all you're going to get is a 2, because remember, casting doesn't round. It just drops the decimal. So even though it's 2.85 something, all you're going to get out of that when you typecast is a 2. And now I'll show you the output for the second part. So for val1, val2, val3, val4, and val5, here are the answers. So for val1, I get a 4.25. For val2, I get 25.4 divided by 5.2, and lo and behold, you get this 4.88, and so on. That's what ends up there. For val3, remember, There's no other parentheses, so the INT only applies to the 25.4. So that'd be 25, but we're still dividing by 5.2. The INT doesn't apply to the 5.2. And so we get 4.807. There you are. Now for val 4, notice the 25.4 divided by 5.2 is in the parentheses. So I take 25.4, divide it by 5.2, and I get 4.88. But then once the division is done, I apply the casting, and 4.88 turns into a 4. Drop the decimal. And finally, for val 5, you see I have INT, I'm casting the 25.4, and I'm also casting the 5.2. So that means I'm going to cast the 25.4, that becomes a 25, and then I'm going to cast the 5.2, that turns it into a 5. So that means it's just 25 divided by 5, and my answer for val 5 is 5. That is how math expressions and casting are used in Java. If you have any questions, please send me an email at kmuldrow@lbcc.edu.